Factoring Polynomials, Group Project by Shamia, Julian, Rosemary, and Micaiah. Before you learn how to factor polynomials, it is important to know some vocabulary. Number 1. Polynomial. An expression consisting of variables, coefficients, and exponents combined using addition, subtraction, and multiplication. Here's an example of a polynomial. Number 2. Factor. A number, variable, or expression that divides another number or polynomial evenly without leaving a remainder. Number 3. Factoring. The process of breaking a polynomial into a product of simpler expressions called factors. Number 4. Greatest common factor, or GCF. The largest number or expression that divides all terms of a polynomial evenly. Number 5. Monomials, binomials, and trinomials. A monomial is a single-term polynomial. A binomial is a polynomial with 2 terms, and a trinomial is a polynomial with 3 terms. Here are examples of all of them. Number 6. Distributive property. A property used to expand expressions or reverse the process of factoring by grouping. Here's an example of distributive property being used. Number 7. Prime factorization. Breaking down a polynomial or number into its most basic factors that cannot be factored further. Number 8. Difference of squares. A special factoring pattern where a squared minus b squared is equal to a plus b multiplied by a minus b. Number 9. Grouping. A method of factoring by grouping terms together, often used when factoring 4-term polynomials. Now we are all done with definitions. Let's start solving some examples. For our first example, we will use the expression x squared minus 16. This expression has 2 terms, x squared being the first term and 16 being the second term, which makes it a binomial. This equation has no greatest common factor other than 1 because the only factors of x squared are 1, x, and x squared. The factors of 16 are 1, 2, 4, 8, and 16. There are no factors common to both x and 16 besides 1. The greatest common factor is therefore 1. Factoring out a greatest common factor of 1 doesn't usually change the expression, so it is usually omitted. To factor this expression, we can use the difference of squares. The expression x squared minus 16 fits the pattern a squared minus b squared, where a and b are terms that can be squared. In this case, a squared is equal to x squared. Therefore, a equals x. B squared is equal to 16. Therefore, b is equal to 4 because 4 times 4 is equal to 16. Now let's apply the difference of squares formula. The difference of squares formula states that a squared minus b squared is equal to a plus b multiplied by a minus b. By substituting our values of a equals x and b equals 4 into the formula, we get x squared minus 16 is equal to x plus 4 multiplied by x minus 4. Now let's check the result using the FOIL method. To verify the factorization, you can expand the factored form using the FOIL method. First, outer, inner, and last. X plus 4 multiplied by x minus 4 is equal to x squared minus 4x plus 4x minus 16, which is equal to x squared minus 16. Since expanding the factored form gives us the original expression, we know that the factorization is correct. Therefore, the complete factorization of x squared minus 16 is x plus 4 multiplied by x minus 4. This means that the expression can be represented as a product of 2 binomials. Now let's move on to our second example. For our second example, we will use the expression x squared plus 5x plus 6. This expression has 3 terms, x squared being the first term, 5x being the second term, and 6 being the third term, which makes this expression a trinomial. There's no greatest common factor other than 1 because the factors of x squared are 1, x, and x squared. The factors of 5x are 1, 5, x, and 5x. The factors of 6 are 1, 2, 3, and 6. Again, there is no factor other than 1 that is common to all 3 terms of the trinomial. A greatest common factor requires a factor present in every term. Since there's no number or variable that divides evenly into x squared, 5x, and 6 simultaneously, the greatest common factor is 1. Now, to factor the trinomial x squared plus 5x plus 6, we look for two numbers that add up to the coefficient of the x term, 5, and multiply to the constant term, 6. Those two numbers are 2 and 3 because 2 plus 3 is equal to 5 and 2 times 3 is equal to 6. Therefore, the factored form of x squared plus 5x plus 6 is x plus 2 multiplied by x plus 3. Let's check our factorization using 4. Our first is x times x is equal to x squared. Our outer is x times 3 is equal to 3x. Our inner is 2 times x is equal to 2x. Our last is 2 times 3 is equal to 6. Combining these gives x squared plus 3x plus 2x plus 6, which is equal to x squared plus 5x plus 6. This matches our original trinomial, confirming that x plus 2 multiplied by x plus 3 is the correct factorization.